Hello, welcome to Factorio Space Age. In this video I'm going to showcase my design for blue circuits on Vulcanus. It assumes that you've been to Vulgora and that you have access to electromagnetic plants as well as recyclers, and that you've researched coal liquefaction from Vulcanus itself. To showcase this design I'm going to use a mod called Hell mod. In this mod you can add recipes and then you see the output which you can quantify yourself, for example 0.6 per second, and then you see the required inputs. We're going to change things a little bit by using electromagnetic plants. By clicking on the ingredients you see recipes, and you can set these recipes, and also for these you can set the machinery. The machinery by default rounds up to the nearest full machine. We want to override this as well as for the parts, so that we have a little bit more insight in how much machines are being used. We create the copper cables by melting lava, and we cast iron plates also by lava. So we see that we need 2 parts of each machine and 1 each for the molten metals. We create plastic in a chemical plant. We crack all the oil using liquefaction, and then we need some water, which you get from steam, and steam by smashing together calcite with sulfuric acid. Now we see that it also gives us output some petroleum gas and light oil. We don't want that, we want to use it all in here. So we change this to the matrix solver, and then we slightly reorder these rows. So now that we have all of the parts in here, and we see that we just need 1 of each building here for the plastic part. So let's get started with the design. In this design I'm using a 2x2 chunk where I will place down my machines. To the left I have some resemblance of a bus with a belt of calcite, a belt of coal and some fluids, and here we have infinite power. We are creating processing units, and we're just going to place down all the intermediates. Copper cable, iron plates, molten iron, molten copper. Let's flip this by apart, right there. Let's place all the buildings down first. Plastic comes from light oil cracking, liquefaction, water and steam. Everything is rotated the right way. Now let's add some power. You see that everything is powered in a nice horizontal line. And now let's add the inputs. The first input is right there. It's a mixed belt with coal as well as calcite. We input the calcite and coal using inserters. Then we have sulfuric acid. It goes into the steam cracking. And it also goes through to the blue circuits. Then we have lava. Goes into there. plastic as well. Go through here. That's plastic. That's all these inserters. I'm using 2 inserters here, just in case you don't have researched the inserter productivity yet. Then we need a few more things. We need this fluid all the way over there. We need this fluid all the way over there. We need steam. Heavy oil loops into itself and also gets cracked. We make sure that it only gets cracked by reading the contents of the refinery and only enabling the cracking when there's more than 25. I'm setting 25 because that's the required amount. We unbarrel it. Just press 10. And let's output the barrels into an active provider chest. Let's also place down roboports right there and right there to stop the blinking from happening. We're missing a few fluids. That part. Water also goes in. And that should be it. We just need a few of these in here. And then one more thing. This only enables when there isn't enough heavy oil in this recipe. So now there's heavy oil barrels in here, but they aren't required. Otherwise, this system may end up filling all the way with heavy oil from somewhere else. You see that the plastic is being made, goes through here, into this machine, and then we see that we have an output problem with this stone. To the belt, and then let's throw it out. Go all the way to there. That's not the stone part. Okay, so now we have an output as well. So I'll put this someplace. And then the beautiful part about this design is that it is tileable. So that would be right there. Let's not copy the top part. Let's do it right here. We can change a few things. We no longer need these rubber boards as well as the seating, because we can just leach off that stuff right there. Let's make sure that this is all fine. better. So now we can copy this part. Right there. And right there. And for the final one, we need to remember to put down the robo boards again. Now we have clean up a little bit. Go underground here. Then all the processing units can go to the left into wherever they're being used. Right now I'm just throwing them away. And we also see that this is all working perfectly. If you want, you can use a stone, or you can transform it into landfill. I'm going to transform it into landfill right here. And then you can transform the landfill into landfill by using the recycler. So if you alt click on something, you can see the recipe, and you see that landfill recycles into landfill. And then by having two recyclers facing each other, there's an infinite loop of recycling going on. This is already fine as it is. We have 4 of these setups. So in theory, there should only be less than half a belt of stone. But sometimes the system needs to get started a little bit. So in order to fix that, we're going to change these belts so that this bottom half of stone gets turned into the left belt. Now this isn't really outputting, not sure why. Forgot one of these. So now this should work. This one doesn't get plastic because that insert is the wrong way for all of them. And now it should be working for all of them. You see that there's plastic left over on all of the belts. That's fine because there's plenty of plastic. All the surface on the left. Stone is being handled perfectly. There's even one inserted too much probably. But in case you don't have enough inserts or capacity, then this is probably fine. And otherwise you can just have the stone go to the left. There's a few more things that you can do in case you want to use less power. You can use what are these things called? Efficiency modules. Just like this, or maybe just in the right parts, because those are the most power hungry. So that was how much was that? 144. So let me put on some power parts for myself. So roboport, some power. Yeah, that should be fine. And then some robots. There we go. So this lowers the power requirements by quite a bit. So if you see before it was almost 100 megawatts, but afterwards it's more like 25, which is similar to what we saw here in whatever this is called, Helmut. So before, on average it was 88 megawatts. But by lowering the power of these parts, it changes quite significantly. Now there are some things that you could do to simplify this design, to make it a bit cheaper. For example, you can tile this water all the way to there, because you don't need put much water for all of them. But I think it's nice that all of these designs work on their own and that you don't need to worry about messing with these parts. One final thing, in case you want to have just a little bit more productivity out of this one, you can remove the modules, the efficiency modules, and instead use productivity model 2. I'm using productivity model 2 because this is Vulcanus and not Clara. Then speed module 3 because this is Vulcanus. So we're going to find the balance between these two modules, so that the speed is still more than it was and the productivity is more than it was. So now the crafting speed went from 2 to 2.2, that's 10% more, and the productivity went from 1.5 to 1.74. So if we go to the planner, copy this and make a copy. If we then go back to the original part, so we had 1.5. Now the crafting speed is 10% faster, so that's times 1.1. The productivity went from 1.5 to 1.74. Now we are creating 0.7656 if we use that design. And then we just need to make sure that we set the modules, and then this machine is exactly 2 again. So if you want to use some models and a little bit more power, then you can create about 25% more processing units than before. So that's the design. I'll put the blueprint somewhere. Let's just clean up this pipe there. And it's working. Thanks for watching. See you next time.